Up next, we got sections 1.5 and 1.6 of Unit 1. I'm grouping them together because both of these sections are just algebra and applying algebra to limits that we just learned and how they work, right? So first, before we get started with any of the good stuff, you gotta learn about all the rules of how limits work under algebra. So we're gonna speed run, we're gonna get through all of them in like 3-4 minutes, all the rules, and then we're gonna get to some problems and show you how to apply these. So, for example, if you have limits x approaching a of big parentheses f of x plus g of x. F of x and g of x here are just two different equations. We looked at limits of one equation, you look at the graph, look at the table, whatever. If we have two equations and they're added up together in the parentheses like this, it's like, what do you do, right? You have two equations, two limits, they're in a parentheses. What does this mean? All this is you take the limit of the first one, x approaching a of f of x, this is the limit of the first one, and then you just add it to the limit of the second one. It's just that. It's simple. You take the first limit, you take the second limit, you add them together, because that's what it's saying. There's a plus sign in the middle. It's the same thing with subtraction. If you have limit x approaching a of f of x minus g of x, it's the same thing as limit f of x approaching a minus limit g of x approaching a. So the important thing is that like the limit is applied to both of them. If you have the first two, you're not just doing f of x plus g of x and then finding the limit of that, because that doesn't really make any sense. You find the first limit, you find the second limit, you add them. The same thing is true for multiplication and division. So if you have limit x approaching a of f of x times g of x, same thing applies. The limit goes to both. You have the limit of f of x times the limit of g of x. And I'm sure y'all get it by now, but I'm gonna write it anyway. Same thing true for division. If you have f of x over g of x, it's the same thing as limit f of x approaching a over the limit x approaching a of g of x. So you're going to want to solve the limit first before you do any of the operations. So you're going to want to solve the first limit, solve the second limit, and then multiply them together instead of trying to do multiplication and then finding limits. If you have a limit with a number, for example, if you have limit x approaching a of, I don't know, like 2 f of x, right? It's like, what do you do here? Does the function get twice as big? No, you just solve the equation first. X approaching a, not solve, you solve the limit first. So you find the limit, and then you just multiply it by 2. So whatever the number is, again, you do the limit first, and then you multiply by the number afterwards. You could also write this as 2 limit f of x, whatever. So you find the limit, multiply it by 2. The same thing is true for exponents. If you have limit x approaching a of like f of x squared, what would you do here? Do you square the function? No, you don't. You take the limit of the function first, f of x, you find whatever the limit is, you find your answer, and then you square it, or you put power 3, whatever the exponent is, right? I think that's about it for the rules, and now we could get to like math. I was wrong when I was editing this. There's one more. We're gonna go over that real quick. It's compound functions and how do compound functions work in limits. So in pre-calc we learned that if you have like f of g of x, right? If you have this and you have two different graphs, you look at g of x first and then you plug that number into f of x. The same is true when you have limits. If you had like limit x approaching a of f of g of x, in this case, you would find limit of g of x. You wouldn't find g of x. You would find the limit of g of x and then plug that number into f of x. I could rewrite that as limit x approaching a of f of limit x approaching a of g of x. I know I'm going fast through these, so if it didn't make sense, you can rewatch it, but I'm going to be explaining them in more depth going forward and with actual examples to help solidify this knowledge, but this is just things that you know that the limit goes first is the point. All right, moving on. So for our first example, we're going to look at this graph from my best friend Khan Academy. And look, it says this is a graph of h of x, right? So what is the limit of negative 3 of 0.5 h of x. So what do you do here? First, you do the limit first, always. So you have limit x approaching negative 3 of h of x, and then the 0.5, where does that go? You do it at the end. You go times 0.5. So negative 3 on this graph is approaching 4. From the left side and the right side, everybody agrees this is approaching 4. Okay, so this is 4 times 0.5. That's 2. That's it. So for this, you just you find the limit first, you multiply by the number, and you got your answer of 2. It's pretty straightforward. Okay, another example of a problem like this that will be on the AP test that they love to use is it's like compound functions like this, right? So limit, what's asking for is limit based on this graph of x approaching 4 of f of x. So like, what does this mean? Compound functions means you look at the first one first and then you look at the second one. So as always, we're doing limit first. So what this means is you find the limit of f of x, because it's inside the parentheses, what you're doing first. So limit x approaching 4 of f of x, because we're solving inside of the parentheses first. So what is that? On the graph at 4 is 1. Okay, cool. So this is 1. Now we're back to this. So now you're looking at f of 1, because f of x, the f of x here we saw equals 1. So you're replacing this f of x with a 1. So you're looking for f of 1, which is negative 1. So I'll do that again. I'll go slower. First thing you're looking for is this f of x inside the parentheses. You have limit x approaching 4 of f of x. So you look on the graph. When x is approaching 4 from the left side and from the right side, you have a 1. And then since you solved f of x, you plug that back in. You replace this f of x with 1, because they're the same thing. F of x in this case is 1. So they're interchangeable. So you switch it with a 1, and then you look for f of 1, because that's what it says to do right here. And you look at the graph. F of 1 is negative 1. We moving on. Okay, so we learned about compound functions with one graph. We look at f of x. Now we're looking at two different graphs. This isn't a compound function, but it is using two different functions. We have the graph of h of x and the graph of g of x. So you have limit x approaching negative 3 of h of x plus g of x. So what do you do here? You rewrite it, applying the rule that I showed earlier. You have x approaching negative 3 of h of x plus limit x approaching negative 3 of g of x. You apply the limit to both of them. You do it separately, and then you add them. So h of x, limit approaching negative 3 of h of x. Let's look at the graph. You have negative 3 here. Okay, cool. Goes up to 3 from the left side and the right side. Everybody agrees. Limit h of x is 3. Okay, g of x. X approaching negative 3. You look at the graph. Negative 3. Okay, left side, right side. It's all approaching 2. 3 plus 2 equals, wait for it, 5. Boom. Your answer for this is 5. I'm going to do that again. I'm going to go a little bit slower in case you're just taking notes, writing it down, don't understand. When you have this inside the parentheses, you have two different functions. You do them separately. You find both of the limits and you add them together. So the limit h of x first, negative 3. The limit approaching negative 3 of h of x. Look at the graph. It's 3. The limit x approaching negative 3 of g of x. Look at the graph again. It's 2. You add the two together. You have 3 plus 2. You get 5. Easy peasy. Another type of problem College Board is going to give you, or your teachers or whoever, they're going to give you a bunch of information. Right here you have a bunch of y values up here, and then a bunch of limits over here. It's just telling you straight up what they are. And you're going to have to apply those to solve some equation that it gives you. This equation in particular is really long, really cringe. If I saw this on a test, my first reaction when I was in AB would just be annoyed, right? Be like, oh my god, there's a bunch of letters, there's not a lot of numbers, what am I supposed to do? But if you break it down step by step, it's really not that hard. It's simple. You follow the steps. It's easy. So first, what we do, we have this long, cringy thing here in the parentheses, right? So you apply the limit to all of these, and you follow the rules that I said earlier. So you have the limit as x approaches 5 of h of x, because that's the first thing in here. And then what? Times the limit as x approaches 5 of f of x plus 2g of x. So we start with f of x plus 2 limit x approaches 5 of g of x minus h of 5. This minus here separates it. It's its own term. So you don't apply the limit to it. Because this limit is attached to all of these because of the parentheses. It's not attached to this h of 5 at all. So this h of 5, instead of limit h of 5, is just h of 5. So you look on the table here, it's 3. So you have minus 3 at the end. Okay, and you still have this really long, really hard equation. What am I supposed to do with all these limits? Whatever. It's not hard. You take it step by step. Limit h of x literally tells you it's 5. Okay, cool. 5 times what? 5 times, okay, limit f of x tells you right here is 6 plus g of x tells you right here is negative 1 times 2. So you have negative 2. Okay, cool. And then minus 3. So 5 times 4 minus 3 is all this is. So 5 times 4, you get 20. Minus 3, you get 17. And that's it. So it looks really complicated, but it gives you all the numbers that you need. So you just write everything out, look at the table, replace the limits with numbers, replace the h of x with numbers, and that's it. You just plug it all in, do the algebra, and you get 17. Up next, we're going to look at what to do if you just have an equation and you have to find the limit. There's 2 ways to do it. The first one we're going to look at is called direct substitution. It is so easy, so delicious. Look, so this is your equation. I want you to find limit x approaching 0. So how could you do this? You could make a table. You could draw the graph. Both take 20 years. Or you could just plug 0 in for x. So if you're trying to find the limit, you plug 0 in. You're going to get 0 minus 15 over 0 plus 3. So your answer is negative 15 over 3 or negative 5. That's it. It takes 1 second. You just plug it in, get your answer. Very simple. All right, next one. Limit x approaching 4. Okay, you plug it in, you get 8 plus 1 over negative 12 plus 3. So you get 9 over negative 9. Divide that, you get negative 1. And that's it. That's direct substitution. It takes 5 seconds per problem. But the problem is, it's not always possible. Okay, now look at these equations, and you'll see why we can't always just substitute. Because if we try to substitute 0 in for x in this equation up here, you're going to get 0 over 0. And that's not how math works. You can't divide nothing by 0. Definitely can't divide 0 by 0. So what can we do? The second method is factor and cancel is what it's called. So you have to factor it out. So for this one, for example, we could take out x, and you get 4x minus 5 over x. These two things are equivalent. They're just written differently because you factored out an x. Not once you have it like this, you just cancel these x's out. Oh, I should have wrote a limit over here. You always have to write all your limit on all the steps, or you're going to fail calculus. So you cancel out the x's, and then you just have limit x approaches 0 of 4x minus 5. And once you have this, then you can just substitute and just plug it in, and you get 0 minus 5, and your answer is negative 5. So you have to factor it first, and then you can substitute it in and get your answer. So for this one is negative 5. I just erased it to get more room for that. So you have to plug in negative 7 here. If you plug it in, you have x plus 7 at the bottom. You'll get negative 7 plus 7. You'll try to divide something by 0. You can't do that. It's not how it works. Okay, so what do? You have to factor it. So on top, if you factor this out, you're going to have an x plus 7. You're going to have a 2x minus 1 over x plus 7. Oh, look at this. Look at this. You could just cross that out. So you cross these out. They're gone now. And now you just have limit x approaching negative 7 of 2x minus 1. Plug it in. You get negative 14 minus 1, negative 15. Boom. So you factor it first, and then you substitute it in, and you do your little algebra, and you get your little answer, calm little answer. Sometimes you can't plug it in, and you can't factor it, and in that case, the limit just does not exist. So if we're looking at this problem here, we try to plug in -2, we get -2 at the bottom, plus 2, we get 0. You can't divide nothing by 0, so you can't actually plug it in. Okay, well then let's factor it. If you factor this top up here, you get x plus 5 and x plus 3. That is the ugliest 5 I wrote in my life. And x plus 3 over x plus 2. You can't cancel anything, and you still can't plug in the -2. So this limit just does not exist. Yeah, it don't exist. Okay, let's learn how to rationalize fractions with radicals. So for example, if we are looking at this right here, and you try to plug 16 into this, you're gonna get 0 over 0. And that's not good, because then you can't solve it. But you can't really factor that either. So what do? What you do here is you multiply both sides by the conjugate. And what is a conjugate? Well, if you have a plus b times a minus b, these are conjugates right here. And if you multiply this out, you get a squared plus ab minus ab minus b squared. Right? These obviously are going to cancel, and then you're left with a squared minus b squared. So anytime you have two things here where one of them is plus and one of them is minus, and they're multiplied together, and you end up with a squared and b squared, these are called conjugates. This is the conjugate of this, and vice versa. Right? Yeah. So you'd want to take the top, and you want to multiply it by the conjugate, which in this case, this will be a, this will be b. So if you have a minus b here, you need to multiply it by a plus b. So you have a, which is square root x. This minus will turn into a plus because you're looking for the conjugate, plus 4b. And then anything you do to the top, you also have to do to the bottom. So you're multiplying it by the same thing. And if you multiply this out, you have two conjugates times each other, so you're going to end up with a squared minus b squared, which is x minus 4 squared is 16. Over, you're going to have a big thing at the bottom. You're going to have x minus 16 times square root x plus 4. Now, if you see, these cancel out now, and they're gone. And you're left with 1 over square root x plus 4. And now if you plug in the limit to this, you replace x with 16, you get 1 over 4 plus 4, because square root of 16 is 4. So you get 1 over 8, and that's your answer. So we'll go over one more of these because it's a little bit complicated. Now we got a calm little radical problem, and now the radical's on the bottom. So what would we do about this? What could we ever do? We do the exact same thing we just did, except now it's on the bottom, nothing changes. This is a, this is a b, this is a minus. So the conjugate of this is going to have the a, it's going to have the b, but it's going to have a plus because it's opposites. We have to do it to both sides. And then we multiply this out, what do you get? You get x minus 10 times 3 plus square root x minus 1 all over a squared 9 minus b squared x minus 1. So let's make this all super duper small so that we could fit the rest of this problem. You can't forget the parentheses because this negative has to distribute. You have x minus 10 times 3 plus square root x minus 1 all over negative x plus 10. But oh my goodness, nothing cancels. This is x minus 10, this is negative x plus 10. Whatever shall we do? Well, we factor the bottom, we keep the top the same. How did I forget this parentheses twice? That is crazy. Square root x minus 1 over, we're going to factor the bottom, we're going to take out negative 1. So we're going to have negative 1 times x minus 10. And look at that now, cross out, gone. So now you have 3 plus square root x minus 1 over negative 1. And we're going to bring our limit back. When x is approaching 10, you're going to plug 10 in. I need to make even more room. It's very ugly, but you're just gonna have to bear with me. You put the 10 back in, you have 3 plus square root 10 minus 1 over -1. 10 minus 1 is 9. The square root of 9 is 3. So you have 3 plus 3 over -1. You have -6. Boom. You go one step at a time. Take the conjugate. Multiply it. Easy peasy. Easy peasy. Moving on. Next, we are looking at piecewise functions and how to apply limits to them. This is h of x. When x is less than 2, you're going to use this top equation. When x is in between -2 and 1, you're going to use this bottom equation. So what if they ask you for the limit of x approaching -2 from the left of h of x? And then what if they ask you for limit x approaching -2 from the right of h of x? What would you do? Well, for this one, you would plug in -2, and since it's from the left, you're going to use this equation here because x is less than -2. So you're going to use this equation. You're going to plug in -2, which is your limit. So you would get -4 plus 1. So the answer is -3. And for the bottom one, you do the same thing, but now it's plus, right? Because it's from the right side, because it's greater than -2. So you're going to plug -2 in. You're going to get 1 over -2 minus 1, which is 1 over -3. So then what are you going to do if they ask you for limit x approaching -2? And that's just it. No left, no right. From both sides, x approaching -2. What are you doing? Well, you see that from the left, it's approaching -3. From the right, it's approaching -1/3. So your graph is going to look something like this. There's going to be a hole here. So this obviously doesn't work. You get does not exist. If the left side limit and the right side limit are different, the general limit does not exist. So, I mean, yeah, that's it about piecewise. You just apply from the left, from the right is how you decide what equation to use. Or, for example, if this question was asking you for the limit of x approaching 0, let's say, of h of x, or the limit of x approaching -3 of h of x. Okay, well, x approaching 0, 0 is not less than -2, so you're not going to use the top function, so you're going to use the bottom one, or the bottom equation. Because 0 is in between -2 and 1, so you would use this equation here, and you would get 1 over 0 minus 1. So this limit is just -1. And -3, you're going to use this top equation, because -3 is less than -2. So you're going to get -6 plus 1. You're going to end up with -5 as the limit for this one. So whatever the limit is, you look at where the x is, you see which equation it applies to, and you plug it in. And if it applies to both, then you look at if the left and right agree to see if the limit exists or not. And that's it for piecewise right now. The last thing we have to go over in these two sections is special trig limits, is what these are called. So basically, limit x approaching 0 of sine x over x, or x over sine x, they're the same thing. They're both 1. Anytime you see this, answer is 1. Here, 1 minus cos x over x, or cos x minus 1 over x, doesn't matter which is subtracting which, but as long as you see this, and it's over x, and the limit is approaching 0, the answer will be 0. This is kind of just like, gotta memorize this. It's like, it's lame, but sometimes math is lame. But once you memorize this, will be so fun. You'll be like, you see it on the test, that's an instant question, instant point, instant 5 on your exam. You just got to memorize 4 things. 4 things ain't that bad. Like, come on. Yeah, so applying these. We're going to learn about applying these. So, to apply these, we're going to look at these 3 equations right here. So, for the first one, the limit x approaching 0 of sine 5x over x. What we could do here, since we can't plug 0 in, and since this isn't the same equation that we just looked at with sine x over x, we could multiply this by 5 over 5, because the same thing as multiplying it by 1. So that would give you 5 sine 5x over 5x, right? And now if we just look at this part, like the second part, sine 5x over 5x, this is the same thing as sine x over x, right? Sine 5x over 5x is the same as sine x over x. And this equals 1, right? So this we could cross out because this equals 1. So then what you're left with is you're just left with 5. So this will be your answer. Or there's a shorter way of doing it. because if you could see that it's just sine 5x, right? So the answer would just be 5 because there's a 5x here, and these are gonna cancel if you do it, multiply it out the long way. So you could just recognize that pattern, see this is gonna be 5. In this case, you have sine 5x over 3x, right? This is not exactly the same thing, but this, since it's just 5 over 1x is gonna be 5. This, you look at it, you have 5x over 3x. The answer is 5 over 3. That's it. So anytime it's like sine something over something x, you can just take the coefficients and just write them in as a fraction, and that's just gonna be your answer. It's just every time. Shortcut, easy, takes 1 second, and you're done, right? Now looking at this equation on the right side over here, you have cosine squared x minus 1 over x cos x plus 1. And this top, this cosine squared, it's the same thing as cosine x minus 1 squared like this. Is what the squared means. The square there means you like square everything. It's just you could put it either place. It's like interchangeable where you put it for like trig functions. So if you have cosine x minus 1 squared, how could you factor this? You would have cosine x plus 1, and you'd have cosine x minus 1 over x cos x plus 1, right? Because this top part up here factors to this, and the bottom part stays the same. So you have cosine x plus 1 and cosine x plus 1, so these would cancel, and you're left with cos x minus 1 over x, and we saw before that this just equals 0. So your answer for this one would be 0. That's it. That's how you apply these concepts. And we're done with 1.5 and 1.6, so we're going to move on real quick.